Hello everyone, I am Mansi. I'm from the Department of CSCI from Sri Venkateswara College of Engineering. So today's topic is typical CNN, that is convolution neural network architecture. So let's start with the video. So introduction to CNN architecture. So convolution neural network, that is CNN, are the type of deep neural networks. It is designed for processing structured grid data such as images. And CNN are widely used in computer vision tasks such as image recognition, object recognition, and image segmentation. The architecture of CNN typically consists of convolution layer, pooling layers, and fully connected layers. Convolution layers are building blocks of CNN and are responsible for extracting features from the input data. And each convolution layer applies the set of filters to the input layer to detect patterns and features. The output of the convolution layer is called as feature map, which represents the presence of different features in the input data. So convolution layers, input layer, hidden layer, and output layers. Input layer, it is a layer in which we give input to our model. The number of neurons in this layer is equal to the total number of features in our data. And hidden layer, this input, the input from the input layer is then fed to the hidden layers. There, the hidden layers, depending upon our model and data size, each hidden layer have different number of neurons, which can generally greatly than number of features. So the output of each layer is composed of matrix multiplication of the output of the previous layer with the learnable weights of that layer, and then the addition of learnable biases followed by the activation function, which makes the network nonlinear. So the output from the hidden layer is fed to the logistic function like sigmoid or softmax, which converts the output of each class into the probabilistic score of each class of each class. So let's discuss about CNN architecture. The convolution layer applies filters to the image, input image, and extract features. The pooling layer down samples the image and reduce the computation, and fully connected layers make final predictions. So the network learns the optimal filters through backpropagation and gradient descent. Pooling layers are used to downsample the feature maps generated by the convolution layers. Common pooling operations includes max pooling and average pooling, which reduces the spatial dimensions of the feature maps. Pooling helps to make the feature more robust to variations in the input data and reduce the computational complexity of the network. How the convolution layer works. So convolution neural networks or convnets, shortly known as convets, are neural networks that share their parameters. Imagine you have an image. It can be represented as a cuboid, having the length, width, and an height. Generally have RGB, that is red, green, and blue channels. Now imagine taking a small patch of an image and running the small neural network called as filter or a kernel on it, and with say k outputs and representing them vertically. Now slide the neural network across the whole image. As a result, we will get another image with different width, height, and depths. Instead of just RGB channels, now we can have more channels, but lesser width and height. This operation is called as convolution. If the path size is same as that of image, it will be a regular neural network. Because of this small patch, we can have fewer weights. So how convolution neural network works? CNN are trained on large data set using backpropagation and gradient descent. The model performance is evaluated on the separate test set to increase accuracy and generalization. Techniques like data augmentation and transfer learning can enhance the performance of CNN models. So layers to build connets. So a complete neural network architecture is known as connets. The connets is a sequence of layers, and each layer transforms one volume to another. Different differentiable functions. Types of layers. Dataset. Let's take an example by running a connet of an image of dimension 32 into 32 into 3. So input layers, it's a layer in which we give input to our model. In CNN, generally the input will be image or the sequence of images, and the layer holds the raw input of an image with width 32, height 32, and depth 3. And convolution layer, in this layer use we use to extract the feature of the input image. It applies to the set of learnable filters known as kernels to the input image. The filter or a kernel, a small matrix, usually 2 into 2 or 3 into 3 or 5 into 5 shape. It slides over an input image data and computes the dot product between kernel bit and the corresponding input image patch. The output of this layer is referred as feature maps. Suppose we have total 12 filters for each layer. We will get the output volume of the dimension 32 into 32 into 12. So layers to build the connet, and connet activation layers and pooling layer. Activation layer, by addition of an activation function to the output of the preceding layers, activation layers add non-linearity to the networks. It will apply an element size activation function to the output of the convolution layer. Some common activation functions are ReLU, max 0 into x, tan h, and leaky ReLU, etc. The volume remains unchanged, hence the output volume will have dimension 32 into 32 into 12. The pooling layer, the layer is periodically inserted in the connet, and its main function is to reduce the size of the volume, which makes the computation fast, reduces memory, and prevents overfitting. Two common types of pooling layers are max pooling and average pooling. If we use max pooling with 2 into 2 filters and stride 2, the resultant volume will have dimensions 16 into 16 into 12. So this is the image of convolution neural network. And what are the advantages of convolution neural networks? Convolution neural networks are good at detecting patterns, features in image, video, and audio signals. They are robust to translation, rotation, and scaling invariance. End-to-end training, no need to have manual feature scaling. So it can handle large amount of data and it can achieve high accuracy. So what is the disadvantage of neural network? Computational expensive to train, and it requires a lot of memory, and it can be prone to overfitting if not enough data or proper regularization is used. It requires large amount of label data. Interpretability is limited. It's hard to understand what the network has learned. So what are the applications of convolution neural networks? Convolution neural networks has numerous applications beyond image recognition, including object detection, facial recognition, and medical image analysis. So they have been used in autonomous vehicles, surveillance systems, and natural language processing tasks. And CNN continues to drive advancement in artificial intelligence and are key technology in deep learning landscapes. Thank you for watching the video.